Hello children, today I am here to teach you chapter 27 in your textbook, that's scale diagrams. Identify scale diagrams and draw scale diagrams and calculate actual measurements using the scale. So where we use scale diagrams and what are scale diagrams? So think about any large one you want to make it smaller, or very small one you want to make it bigger. For that you need scale diagrams. So we'll see what are the ways we can use scale drawing. So here, look at this plan. This is the plan of the floor area of a house. It says bedroom, kitchen. So everything clearly see. The sizes are there. So this is the size, actual size has been decreased, reduced. This is a map of Sri Lanka. So we can see the size is reduced. What about this one? This is a blood vessel. That one, normally the blood vessels are very small. So it has been increased. So if you want to see smaller ones bigger or bigger ones smaller, we use scale diagrams. Now we'll see how we can select the scale. So write down 3 instances where the actual size is reduced. Actual size is reduced. So we can write maps. Maps, we take bigger one, we reduce the size. And land area, so land plans. So land area is big, so we are reducing to a smaller one. So what else? So if you want to construct a building or something, construction, so construction of a building. So that's architecture. He or she needs to draw a plan for that. So that's a bigger one. You reduce the size. Now we'll see 3 instances where the actual size is increased. Very small one. So blood vessels to see, or cells in our body to see, cells in our body. And in laboratory, we use the microscopic and we look at smaller things, cells, and we make it bigger. So basically, very small ones. So give me another example. So we wrote blood vessels. Sometimes we look at small insects to see germs or something. We'll take in the laboratory, we'll look at germs inside, how it distributed, very small particles. So here to see germs in a cell or something. So figures are drawn by increasing or decreasing measurements by a common ratio. So this is important. When you are make it bigger or smaller, you have to increase or decrease with a ratio. So that's called, the whole diagram is called the scale drawing. The ratio we are selecting is called the scale. Look at this diagram. We can see A is this figure. And here, same size figure is drawn here. So, A and B both are the same. Now, when you look at A and C, what can you say about this one? So, here to here, same. A to C, here to here. Now, see this side 4, this side 2, 3, 4, 5, 6, and 8. Here 4, this side also 8. This is 4. So, all sides doubled, twice as A. So, the size also twice as A. So, this is doubled or twice as the original one. What can you say about A and D? This is 1. 2 becomes 1. Here 4 becomes 2. 4 becomes 2. So, here to here, this is half of the size. So, reduced by half. So, this is halved. I'll write half. So, all these are scale drawings. So, the ratio we use, that's the scale. So, here ratio is 1 to 1, 1 to 2 and 1 to half, 0.5. Scale. Can we draw AB 20 meter length on a paper? So, it's not possible. Not possible to draw. What is the best way to draw that on a paper? So, we have to select a scale. So, we have to reduce the size. Select appropriate scale. So, we say appropriate scale. Now, we'll take this scale. 5 meter. Actual length is 1 centimeter. Scale drawing length. So, we can say 5 meters to 1 centimeter. So, we use arrow to represent the scale or the ratio. As a ratio also you can write down. So, here you need to show 20 meter length. So, according to this one, this becomes multiplied by 4. So, you have to do the same thing, that's multiplied by 4. So, you get 4 centimeter length. So, what you can do, if you want to draw 20 meter length, so you can use this scale and only measure 4 centimeter length to represent AB. Write 1 centimeter, 5 meters as a ratio now. Same scale we'll take as a ratio. So, 1 centimeter, 5 meters. Now, we'll convert to centimeters. So, what's the conversion? 100 centimeter is 1 meter. Multiply by 100. So, you get 500 centimeters. So, when we are writing as a ratio, so we can write 1 centimeter to 500 centimeters. So, both units are the same. So, you don't have to write down units in ratio. So, you can write 1 to 500. So, that's the scale for this scale drawing. So, we call scale. So, there are 2 ways you can represent the scale, as a ratio or using arrows you can represent. Write the following scales as ratios. So, 1 centimeter, 3 meters. Convert to centimeters. That's 300 centimeter. Multiply by 100. So, what's the ratio? So, 1 to 300. 1 to 300 because Both are in centimeters. 1 centimeter represents 7 meters here. So convert to the same unit. That's multiplied by 100. 700 centimeters. So what's the ratio? 1 to 700. This one 1.5 meter is 1 centimeter. So multiply by 100, you get 150 centimeters. So this is 1 to 150. 1 centimeter represents 25 meters. So 25 times 100, 2500. So what's the ratio? 1 to 2500. 3 centimeter represent 900. So 3 centimeter 900 means both are centimeters. So what about 1 centimeter? So you divide this by 3. Do the same thing. Divide by 3, you get 300. So that means 1 centimeter is 300 centimeters. So what's the ratio? 1 to 300. Look at this one. 11 centimeters is 330. So we need to find out what's 1 represent. So here divide by 11. So do the same thing. Divide by 11. You get 11 times 3. 33. So 30 centimeters. So 30 centimeters means what's the ratio? 1 to 30. Because both are in centimeters. Write down the following ratios as a scale using arrows. So now ratio is given. So we'll use the arrows to represent the scale. 1 centimeter means 500 centimeters. So we need to convert to meters. So we can divide by 100. 5 meters. Ratio is 1 to 300. That means 1 centimeter represents 300 centimeters. Divide by 100. That's 3 meters. So 1 centimeter represents 3 meter length. 1 to 700. That means 700 centimeters. So 700 means when you divide by 100, that's 7 meters. 1 centimeter represents 7 meters. 1 to 1000. That means 1000 centimeters. Divide by 100, you get 10 meters. 1 centimeter represents 10 meters. Ratio 1 to 5000. That means 5000 centimeters. Divide by 100, that's 50 meters. 1 to 50,000. So that means 50,000 centimeters. You can divide by 100. So you get 500. And if you are dividing by 1000, again you can get kilometers as well. So if you are writing in meters, that's 500 meters. Or if you are dividing by 1000, again 0.5 kilometer also you can write. 5 centimeter represent 2500 centimeters. Write this as a scale and then as a ratio. So 5 centimeter represent 2500. Both are in centimeters. So we can find for 1 centimeter. Divide by 5. You get 500 centimeters. So 1 centimeter is equal to 500 centimeters, or you can write as a ratio. What can you write? We can write 1 to 500. And if you want to write using arrows, we can write 1 centimeter represent this one, divide by 100 and write 5 meters. 7 centimeters represent 350 centimeters. Write this as a scale and a ratio. So you have to find out for 1 centimeter what's their length. So divide by 7. So that becomes 50 centimeters. So 1 centimeter is 50 centimeters. So you can say 1 centimeter. If you are writing this one, you can write 50 centimeter, or when you are writing in meters, you have to divide by 100. So 0.5. Either you can write 50 centimeters or 0.5 meters. So what's the ratio? We take both in centimeters, 1 to 50 ratio. 8 centimeter represent 80 millimeters now. So 80 millimeters convert to centimeters, divide by 10. So you get 8 centimeters. So what is 1 centimeter represent? Divide by 4, 2 centimeters. So you get 1 centimeter represent equals to 2 centimeters. That means what's the ratio? Here we can write, without writing the equal sign, the ratio sign. So 1 centimeter to 2 centimeter without centimeters. What's the ratio? 1 to 2. 1 centimeter means 0.2 centimeters. So multiply by 5 now, because you have to get rid of this decimal. So multiply by 5, you get 5 times 2, 10. So 1 centimeter here. So 5 centimeter is 1 centimeter here. So same thing here applies. So 5 to 1 ratio. So 5 centimeter is 1 centimeter. Ratio becomes 5 to 1. Both in centimeters. Find the map length if the actual length is 15 meters to the scale 1 to 500. So what is 1 to 500 means? 1 centimeter represent 500 centimeters. Now we can write, this is in meters. 500 means divide by 100, 5 meters. 5 meters represent 1 centimeter on the map. So what about 15 meters? What you do? You multiply by 3 to get 15. So do the same thing. Multiply by 3. 3 times 1, 3. So what's the map length? 3 centimeters. Look at this diagram. Figure shows the actual measurements of a rectangular hall area. So you have to take the scale as a suitable one. 12 and 8 is there. What do you think the suitable scale? So we'll take 1 centimeter represent 2 meters. Then actual length is 12 meters means what? That means multiply by 6 to get 12. So you'd have to do the same thing. So multiply by this one, you get actual length 12. You can represent from 6 centimeters. What about width? That's 8 meters actual width. So when you divide by 2, you get 4 centimeter is the scale width. So 6 and 4. Using straight edge and the protractor, draw the figure to a scale. Use protractor to measure 90-degree angles. So here is a rectangular shape. So 90 degrees, so perpendicular means 90 degree. So you can use the protractor. So 12, 8 and 6 and 4. So we need to construct 12, 8 means 6, 4 centimeter length. Now we'll take the ruler and first we'll draw a straight line with 6 centimeter length. So 6 centimeter this side. So here we can draw a line 6 centimeter here, up here to here. So that's 6. Then what you do? You can take the protractor and measure. You can mark 90-degree angle. You can mark 90-degree angle here. And here also you can mark 90-degree angle because perpendicular line. So here and here. Now you can take the ruler, connect this edge with here. That's 90-degree angle. This edge with here, that's 90-degree. And now we have to measure 4 centimeters. 4 centimeter length, we can use the ruler and measure 4 centimeter length. Here, 4 centimeter length here. So here and here, 4 centimeter length. Now you can connect these two points. So that's the rectangle drawn to the scale. So 6 centimeters and 4 centimeters. So these are 90-degree angles. And what's the label? A, B, C, D, 12 and 8. A, B, C, D. This is 12 meters and 8 meters. Keep protractor on A and B points to draw perpendicular lines. Mark D and C point 4 centimeter away from AB line. Complete ABCD rectangle. Look at this one. Figure shows a rectangular land with length 24 and width 18. Draw a scale drawing and divide the land into 4 equal parts. So we have to draw 24 meter length and 18 meter. So we'll take 2 meter again. 1 centimeter represent 2 meters. So what's the map length? Map length 24 becomes divided by 2. That's 12 centimeters. Map width 18 divided by 2. That's 9 centimeters. So we have to draw 12 centimeter length and 9 centimeter width rectangle. So we'll take the ruler. We'll first draw the 12 centimeter length line segment. So we'll start from here. First we'll mark it here to here. 12 centimeter. So this is the other mark. So that's this side. What about the other side now? 9 centimeter. So before that we'll take the protractor and measure 90-degree angle so that we can draw the perpendicular lines. So here and here 90 degrees here. Now we can take the ruler and connect. Now 9 centimeter length we have to measure. So we'll take the ruler, keep on top of this line and measure 9 centimeters. So we need a bigger length. So 9 centimeter is actually somewhere here. So we'll connect it. When you are drawing, make sure that the space is enough to draw. So this is 9. Again to this point. Again you can measure 9 centimeters. 9 here. And we need to extend this line. Then we need to extend this line. Now we have the point and take the ruler and connect here to here. So what's the diagram here? 90 degrees, all these 90 degrees. And this represents 24 meters and 18 meters. Now we'll look at examples in your textbook. Example number 1. Express as a ratio the scale of a scale diagram where 200 centimeters is represented by 1 centimeter. So 1 centimeter represent 200 centimeters. Both are in centimeters. So you can straight away write down the ratio. 1 to 200. You don't need to write down the centimeters. Both are equal. Express as a ratio the scale of a scale diagram where 9 meters is represented by 2 centimeters. So 2 centimeter represent 9 meters. Now we can't write a ratio because the units are different. Convert to the same units. So you can write this is equal to 9 into 100. 9 into 100 means 900 centimeters. Now both are in centimeters. Now we need 1 centimeter here. So divide by 1. So what is 1 centimeter means? 900 divided by 2. So you get 450 centimeters. Then what's the ratio? 1 to 450. Don't write centimeters when you write the ratio. Example number 3. Express as a ratio the scale of a scale diagram where 2 millimeter is represented by 1 centimeter. So this is smaller one to a bigger scale. So here you can say 1 centimeter to 2 millimeters. And convert to the same thing. Here multiply by 10 here to convert to millimeters. 2 millimeters. Divide by 2. 5 millimeter is 1 millimeter. So that means what's the ratio? 5 to 1. So 1 millimeter small length you can multiply by 5. So you can make it 5 times bigger than the smaller one. So the ratio is 5 to 1. Exercise 27.1. Express the scale as a ratio in each of the following cases, representing 1 centimeter and 20 centimeter length. 1 centimeter, 20 centimeter. That means 1 to 20 ratio. 2 centimeter represent 8 meters here. You have to convert to centimeters. Multiply by 100. 800 centimeters represent 2 centimeters. Divide by 2. 1 centimeter means 400 centimeters. So you can write down the ratio as 1 to 400. This one, 4 centimeter represent 1 meter. Convert to centimeters. Multiply by 100. That's 100 centimeters. Is 4 centimeter. Divide by 4. You get 1 centimeter represent. Divide by 4. 4 times 2, 8 and 5. So 25 centimeters. So what's the scale? 1 to 25. This one representing 1 millimeter by 5 centimeter. So that's a smaller one. Make it bigger. So we can write 5 centimeter represented by 1 millimeter. Convert to millimeters. Multiply by 10. 50 millimeters is 1 millimeter. So you can write without millimeters. That's 50 to 1. So you can make bigger than this one. It's 50 times bigger. What about this one? Representing 6 millimeters by 3 centimeters. So 3 centimeters for 6 millimeters. Multiply by 10 here. 3 times 10. 30 millimeters is 6 millimeters. Divide by 6 both sides. 1 millimeter is 5 millimeter there. So that means the ratio is 5 to 1. Exercise 27.2. The length of a hall in a particular school is 20 meter and the width or breadth is 8 meters. So 20 and 8. Select a suitable scale to draw the floor plan of the hall and write it as a ratio. Draw a scale diagram of the floor plan of the hall. So 20 meters and 8 meters. So we have to select a suitable scale. So what do you think we can take? If you take 1 centimeter, represent 2 meters, you have to take 10 and 4. So 10 centimeter and 4 centimeter. If you take 10 meters is 1 centimeter. So that's too small. 2 centimeters here. So which one is suitable? So we'll take 2 meters. So 1 centimeter represent 2 meters. Now, what's the map length? Map length is 20 meters there. So you have to divide by 2. So that's 10 centimeters. Map width (8) divided by 2, you get 4 centimeters. So you have to draw a rectangle with length 10 centimeters and 4 centimeter width. So we'll draw it now. So what you do? You take the ruler and we need 10 centimeter length. So we can draw a line segment with 10 centimeter length here to here. Then you need the protractor to measure the angle 90 degrees. So here to here 90 degrees. So here this is 90 degrees. Again take this point and draw the 90 degree angle. and you can connect it here to here and here to here. We'll draw it here. And now you need this side with 4 centimeter width. So we'll take the ruler and measure 4 centimeter length from here. 4 centimeters. So here, from here, 4 centimeter here. And again, from here, 4 centimeters. So this line. Now we can connect. So here to here. So that's the map. So what's the length? We took 2, so that's 10 centimeter or actual length. We'll write actual length, 20 meter length, and here 8 meter width. So you can later, you can erase these lengths because this is extra. And here you can mark these angles are 90 degrees. The side length of a square-shaped land is 24 meters. Draw a scale diagram of the land using the scale 1 to 600. So already scale is given, 1 to 600. What it means? 1 centimeter represent 600 centimeters. We'll convert to meters. 1 centimeter, 600 centimeters. Now convert to meters, divide by 100. So this becomes 6 meters. 1 centimeter, 6 meters. So now we need to convert 24 meters to the map length. So what is 24 meters means? Multiply by 4. So you have to do the same thing. So that means 4 centimeter length. So what you have to do? You have to take 4 centimeter length square. So we'll take the ruler. First, we'll measure 4 centimeter length here. And now use the protractor and measure 90-degree angles. Here, here. Now you can use the ruler and connect. Here you don't need to draw long lengths like this because 4 centimeter we need to mark. Now you can use the ruler and measure again 4 centimeter length. Here to here, 4, here, and again this side 4 centimeters. Here. Now we have 4 centimeter length. So this is the square with 4 centimeter length. So this angle is 94 centimeter. But actual length is 24 meters. The length of a rectangular building is 30 meters and the width is 18 meters. Select a suitable scale to draw the scale diagram of the floor of the building. Draw the scale diagram of the floor of the building using the selected scale. So 30 meters and 18. So what's the suitable scale? If you take 6 meter for 1 centimeter, you have a small diagram 5 centimeter and 3 centimeters. So when you take 2, 15 and 9. So we'll take 2 meters. 1 centimeter represent 2 meters. So that's our scale. Then we can say what's 30 meters means. So map length. That means this is 30 here. So that means divide by 2. 15 centimeters there. What's the map width? Actual length is 18 meters. Divide by 2, 9 centimeters. So we'll take 15 centimeter length to one side. So we'll take and 15 and 9. Where we can use 15. We'll take 9 here and to this side we'll take 15. 9 we can draw here. So we'll take 9 centimeter length this way. So here to here. Now take the protractor and measure 90-degree angles to these 2 points, 2 ends, 90-degree angles. Here, here. Now with the ruler, you can draw the perpendicular lines. So we'll draw a big one because we need to measure 15 centimeters. So we can draw 2 lines like this. Now we have to measure 15 centimeters. So from this point, we can extend the ruler. So we get 15 centimeters. So that's here. And here again keep the ruler and mark 15 centimeter here. Now you can draw the straight line here. Connect those 2 points. Connect these 2 points. You can get the rectangular shape figure. So this is, we took 9 centimeter means 18 meters this way and 30 meters this way. 30 meters. So this is the rectangular building. Example number 1. A square-shaped land is drawn to the scale 1 to 400. 1 to 400. The side length of the scale drawing is 2.5 centimeters. Calculate the side length of the land. So 1 centimeter represent 400 centimeters. So convert to meters. So you get 1 centimeter represent 4 meters. Now we need 2.5 centimeters. So that means multiply by 2.5. 4 times 5, 20. 4 times 2, 8 plus 2, 10. So 1 decimal point. So you get the actual length of the land is 10 meters. What length in a scale diagram drawn to the scale 1 to 10,000 represent an actual length of 1 kilometer? So 1 centimeter represent 10,000 centimeters. Divide by 100, you get 100 meters. Now divide by 1000 again to convert to kilometers now. You get 0.1 kilometer. Now we can think about other way around. 0.1 kilometer means, what's the length? 1 centimeter. And we need 1 kilometer. So that means you multiply by 10. So that means 10 centimeter length. Exercise 27.3. In a map drawn to the scale 1 to 200, find the actual length represented by 3 centimeters. 1 centimeter represents 200 centimeters. What about 3 centimeters? Multiply by 3. 3 times 2, 600 centimeters. Or you can convert to meters and write 6 meters. Find the actual length represented by 5 centimeters. So 1 centimeter is 200 centimeters. 5 centimeters means multiply by 5,000 centimeters. So divide by 100, you get 10 meters. What length in the map represent an actual length of 8 meters? So other way around. So we'll convert this one. Now 1 centimeter here, we'll take other way around. 200 centimeters represent 1 centimeter on the map here. This is actual length. So actual length is 8 meters. So first we'll convert this to meters. Divide by 100. 2 meters is 1 centimeter. Now 8 meters means multiply this by 4. 4 times 2, 8. 4 times 1, 4. So then we have to take 4 centimeter map length. In a map drawn to the scale 1 to 200,000, what is the actual distance between two cities indicated by a distance of 7 centimeters? So 1 centimeter represent how many centimeters? 200,000 centimeters. We'll convert to meters. Divide by 100. 2,000 meters. Divide by 1,000 again. You get 2 kilometers. 1 centimeter represent 2 kilometers. So what about 7 centimeters? Multiply by 7. 7 times 2, 14 kilometers. What length in the map represent a distance of 1 kilometer? So 2 kilometers is 1 centimeter. Now we have to do other way around. So 1 kilometer means you have to divide by 2. 1 divided by 2, half of a centimeter or 0.5 centimeter length. Or you can multiply by 10 and write 5 millimeter length. If the distance from Colombo to Balangoda along the A4 road is 142 kilometers, what is the distance between the two cities in the map? So 142 kilometers. So we'll take this one. 2 kilometers represent 1 centimeter on the map. So what about 142 kilometers? So 1 divide by 2 and multiply by 142. 2 times 7, so 1. 71 centimeter length. A scale diagram of the ground floor of a multi-story building in a school is shown below. The floor plan consists of 3 classrooms, a library, a corridor. The scale is 1 to 200. Find the actual length and width of the classroom in meters. So 1 centimeter represent 200 meters. That's the scale given. 200 centimeters. That's the scale given. So each length is here. This one is 2. So what's the length of the full area? Let's find the actual length and width of a classroom. Only one classroom. So one classroom is 2 centimeters. So that means 2 centimeter represent, multiply by 2, 400 centimeters, or in meters, that's divide by 100, 4 meters. So classroom, if you take only the classroom, this is the classroom, 3 classrooms and 1 library and the corridor. Classroom length is 4 meters and width also 4 meters. So that's a square. That's the first part. Find the actual area of a classroom. So area becomes, what's the length? 4, 4. So 4 times 4. So we can write 4 times 4, 16 square meters. Find the actual area of the library. So before that, we need to find out the length and width. So 5 centimeter and 2 centimeters. So length becomes 5 into, what's 1 centimeter is, 1 centimeter means 2 meters. So 2 times 5, that's 10 meters. So what's the width? Width is 2. So that means 4 meters there. So what's the area of the library? Area becomes 10 times 4, 40 square meters. Find the actual area of the corridor. Now we'll take the corridor, 0.5 here. And what is this side? 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11. 11 and 0.5. So 11 centimeters and 0.5 centimeters. Now we'll find out the actual length. 1 centimeter means 2 meters. So 11 means 2 into 11, that's 22 meters. 0.5 times 2, that's 1 meter. So area of the corridor, 22 times 1, 22 square meters. The floor plan of a house is shown in the figure. The scale is 1 to 200. Find the actual width of the door, D1. D1 is 0.5 centimeter. 1 to 200. 1 centimeter means 200 centimeters. So we need 0.5. 0.5 means you are dividing by 2. Divide by 2, that's 100 centimeters, or divide by 100, you get 1 meter. So what's the width of the door? D1, 1 meter. Find the actual length of the window, W1. This one. It says 0.7 centimeters. So 1 centimeter is 200 centimeters. We need 0.7 centimeters. Multiply by 0.7. 200 into 0.7, you get 14 and 2 zeros, but you have to keep one decimal point. 140 centimeters. Or when you divide by 100, you get 1.4 meter. Find the actual length and width of the bedroom and hence find the area of the bedroom. So where's the bedroom? Here. 1.7 and 1.5. So we need to use the scale. 1 centimeter, 200 centimeters. 1 centimeter, 200 centimeters. Then what about 1.7? Multiply 200 into 1.7, or you can divide by 100 to convert to meters. 2 times 1.7. 2 times 7, 14, and 2 times 1, 2 plus 1, 3. So 3.4 meters. Then what about the other side? 1.5. 1.5 centimeter means here 2 into 1.5. That's 3 meters. So that's the length of the room and this is the width of the room. So what's the area? So find the area of the bedroom. 3 times 3.4 square meters. 3 times 4, 12. 1 remaining. 3 times 3, 9 plus 1, 10. So 10.2 square meters. Find the area of the living room. So where's the living room? Here. 2.5 and this side 1.7 and 1, 2.7. So we need to find out for 2.7 and 2.5. Length 2.7 then into 2 meters. So you are multiplying this by 2. 2 times 7, 14. 2 times 2, 4 plus 1, 5. That's the length. Width 2.5. 2.5 into 2. That's 5 meters. Now what's the area of the living room? 5 times 5.4. So 5 times 4, 20. 2 remaining. 5 times 5, 25 plus 2, 27. So 1 decimal point. So this is 27 square meters. It is proposed to lay tiles in the living room. Estimate the number of square tiles of side length 50 cm required for this purpose. So we need to find out how many tiles we need to lay in the living room. Now 50 cm length. So along the length, number of tiles needed. Number of tiles needed. So length is 5.4. 5.4 convert to centimeters, multiply by 100. 540 centimeters. Divide by 50 and see 5 times 1 and 0 and here 4 over 5. That means we need 11 tiles along length. How many tires we need along the width? What's the width? 5 meters. That means 500 centimeters divided by 50. You need 10 tires. So total number of tires is, just multiply these two. Length into width. Total number of tires. Because lengthwise 11, widthwise 10. 11 times 10 tires we need. 110 tires altogether. So we covered all theory related to scale drawing. So when a scale diagram of a shape is being drawn, it has to be done by decreasing or increasing the measurements by a common ratio, depending on the size of the shape. The ratio of a unit length to the actual length represented by a unit length in a scale diagram is considered as the scale of the scale diagram. So when you are writing the scale, you can write as a ratio, something like this, or you can use arrow to represent the scale. So you can say 1 centimeter represent 2 meters. So you can draw big diagrams to a scale and practice how to make a scale drawing.